So sour taste and odor. I'm just gonna say because it's a sense. It's one of your five senses to taste something and smell something. We'll go ahead and put that as physical. In some books and some notes, they do sometimes do it as chemical, especially sourness, because sourness means acidity, and acidity is a chemical thing. The concept of acid is purely chemical. But if you taste it, you can taste some gas, like water or gasoline, to determine which it is without doing any chemistry on the gasoline or the water. Um, so if you can observe something without changing the identity of it, it's a physical property. One thing you can use, one of the most important things you can do with physical properties is you can use it to separate mixtures. For example, if you have salt water, how can you extract the salt?
By heating water up.
You can boil the water away and you'll be left with salt. Thus, you can separate the water and salt by boiling the water. And if you have some way of collecting the steam, you can get the water back too. What's another thing? Magnetism. If we have iron, let's say we have paper clips and sand, we can get a magnet to separate them out. What about oil and water?
You can use fermentation.
What now?
You can use fermentation.
So if you put oil on top of water,
Oil is less dense, less flow.
yes, oil is less dense and it'll float upward. We can separate them out by using the fact they have different densities. And using a syringe is one way of doing it. Decantation is the preferred way. Does anyone know what decantation is?
No, sir.
There are two ways of decanting. Decantation. Or to decant. There are two ways. There's the less precise way. Let's say that we have some water and some oil. And we can pour it off. We can pour the oil off. This is known as decanting something. Basically, because the oil floats, we can slowly pour off the oil. The more scientific way of doing it is we have this funnel that has a little valve. In labs, this is how you would do it. We have water and we have oil. Because this funnel is so small, we can turn the funnel on and let the water drip outward, and we'll be left with oil up top. It's the same thing as pouring it off, but this is known as decantation, and it uses the fact that oil is less dense than water, and thus floats on water. Another physical property. So the physical property, one of them is density. Because of density differences, one floats on another. The other property is solubility. Oil does not dissolve in water. Because it doesn't dissolve, it'll float on top. So both of these are physical properties of oil and water, and we can use it to separate them out.
But if it's called oil instead of cooking oil, is that different?
Grab a pass. What was it?
If black oil, it seems to the bottom.
So some oils do. It just depends on the oil. So cooking oil is less dense. Motor oil might be more dense. It just depends on what type of oil. Here, I'm just using the most common oil y'all encounter, which would be vegetable oil, what you cook with. A physical change is a change in the form of a substance without changing its identity. This means that the properties will remain the same and is usually reversible. It also can be used to separate mixtures. So dissolving something together. So dissolving and grinding is an example. Here's an example that you can use to separate. Let's say that you have some sugar and you accidentally spill oil all over it. How can you separate the oil and the sugar? Yeah, you spill a whole bunch of vegetable oil all in your container full of sugar. You've ruined your sugar. You don't want sugar and oil in your coffee if you put sugar in your coffee. How could you clean this up? If I had a big container of water, what would happen when I put the sugar and the oil together inside the water? The sugar is going to dissolve. And the oil will not dissolve. We can then decant the oil, meaning pour the oil off, and we'll end up with sugar water. And how can we separate the sugar and the water? We can boil the water away, leaving behind sugar. That's literally, if you're curious of how sugar is made, that's basically what they do. Is they take, like sugar cane, they grind it up, they powderize it, and then they put it in alcohol. Some things can dissolve in alcohol, some things cannot. Depending on whether or not sugar will dissolve on alcohol, it'll either form a precipitate, meaning a solid, or it'll form, what they do is they keep putting it in various components. And they save whatever component is the sugar stays in. So either they put it in a liquid where the sugar doesn't dissolve, and everything else dissolves in it, and you just collect the powder by running it through like a coffee filter. And so you have the sugar and some other things. Then you put it in some water. The sugar is going to dissolve in the water along with some impurities. And then you boil it away and you're left with sugar and impurities. Then you usually take that and put it into something else, some other chemical. And so you put it in a chemical that won't dissolve the sugar but will dissolve all the impurities. And then you use a coffee filter, you filter out the sugar, and you're left with very pure sugar. That's how almost every chemical in the world is made. It's always made with some impurities, and that's how you get rid of the impurities. That's how you get pure chemicals. Is we keep putting it in, either it'll dissolve, in which case we filter away the impurities right through a coffee filter and block some of the impurities, or it does dissolve and we boil away the liquid, or we filter it, then we boil away the liquid, and we're left with whatever chemical. And this is all physical properties. A chemical change actually changes the identity of the substance. The properties of that chemical are changed. So the property of that substance is changed. It is usually irreversible, meaning you cannot reverse the process. And we have signs that can usually indicate that chemical changes occur, such as a color change, a formation of gas and solid, the release of light and heat. Examples would be burning and rusting. An object is a chemical change. A chemical property is a characteristic that indicates whether a substance can undergo a specific chemical change. So it's a chemical property is something that just indicates whether or not it will change chemically. So it's something flammable. That means it will react with oxygen. Um, or burn. It'll catch on fire. If something will rust, that indicates whether or not it'll slowly oxidize with oxygen. If something is corrosive, means it'll react with something else. So flammability and reactivity are examples. So a physical change is a change in a substance that does not change what the substance is. Examples include a change in shape, a change in size, a change in phase. Note that a change in phase is a physical change. So something evaporating, something melting, and Michael, wake up and pay attention and keep your mask on. So if you evaporate, if you boil, if something melts, if something freezes, this is just a change in phase. So melting, boiling, evaporation, condensation, freezing, sublimation, deposition, all of those is just physical changes. A physical change can be grinding, cutting, crushing, bending, breaking, heating or cooling, or squishing. Evidence that a physical change has occurred is a change in shape, a change in form, a change in size, a change in phase, and usually physical changes are reversible. If you freeze some water, you can unfreeze it. So rust, therefore, is a chemical change, not physical. That's not converting that. That's just throwing it away. That's like saying, "Look, I can unfreeze an ice cube. You take the ice cube and throw it in the trash." Or I should say, you can refreeze. You're just throwing it away. You're not converting it back. So what can you do to physically change these objects? Physically change. Eating the cookie would be chemical.
Oh, you break the cookie.
So you can break it apart. You can take a bite. Taking a bite will isn't yet doing anything chemical to it. Squishing the orange cookie, melting the ice cube. All these are example of
Heating up the orange.
heating it up. That's physical. Some people have frozen oranges. A chemical change is a change in which the substance is changed into a different substance. You've changed what it is. Examples of chemical changes is burning, rusting, tarnishing, decomposing, polymerization.
Is polymerization normal? I know we didn't jump from before like that and blue. Well, it's like a kettle, right? So I keep trying to get how close. No.
So polymerization is whenever small molecules come together to produce large chains, chemical chains, like they repeating structures. It's a very advanced thing. Have you ever seen glycol? I don't know how to pronounce it. It's like glycerin. It's where the molecules like form long chains and they kind of stick together, kind of like slime. Chemical changes occur when a chemical reaction causes bonds between atoms to break or to form. So either you're adding new atoms to the molecule or you're breaking that molecule up. We're not going over the we're not doing chemical reactions right now. I will indicate this. Combustion is when a substance combines with oxygen and releases energy. Rust and fire are two examples of combustion. It just means that you add oxygen to it and energy is released. Rust is very slow combustion, and wood burning is very quick combustion. So evidence that a chemical change has occurred might include a color change, an odor change, formation of a precipitate. So again, precipitate is a solid that's created when two liquids combine. This image is shows this a liquid and another liquid. Whenever they meet, one's an acid and one is some chemical. When they mix together, they react and it forms pure sulfur. So sulfur is a yellowish powder. But the sulfur was originally attached to some chemical, but when they react, the sulfur breaks off of that chemical, and it forms a precipitate. Gas is formed. You see bubbles, changes in physical property. Did I explain the Mentos yesterday? So Mentos is an exception to a chemical change that produces bubbles. It is not a chemical change. So as I said, so as I just said, if you have sugar and water, if you evaporate the water, you'd be left with sugar down here, right? This is physical change. You are converting water from liquid to gas. If you have a Coke, so Coke with CO2 dissolved in it. The CO2 is dissolved. When the CO2 evaporates, it is falling out of solution. So when it evaporates, that's a physical change. It's going from being dissolved to not dissolved. The Mentos example has to do with the fact that very microscopically, if you were to zoom in, you have little tiny holes in the Mentos. These little tiny holes allow CO2 to fill the hole and come out and keep your mask on. All Mentos does is speed up the rate at which CO2 falls out of solution. And as you've no doubt seen, it's very, very fast.
I have a question.
Yes.
If we're supposed to be wearing masks, but we don't have ski masks.
As long as it doesn't go on your head, sure. Which means you have to pull it back down and basically wear it exactly how you're wearing that.
I just thought it was like skinny tight mask without missing words. So would a bomb be considered a stimulant?
Yes. Actually, usually it's decomposition. So I'll even show it. So decomposition is when one thing breaks apart into two things. And that's usually how bombs explode, is the chemical breaks apart and releases energy. There is some, like gasoline. Gasoline combusts when it explodes.
Yeah.
And that is when it combines with oxygen to release energy. decomposition is whenever it breaks apart to form energy, but we're not going over equations yet. So during a chemical change, energy can be released in the form of heat or light. So glow sticks, for example, is an indication of a chemical reaction. Note that you have to break the glass cylinder inside of it to release the chemical. What type of reaction most likely goes on in fireworks? What type of reaction?
Chemical.
Chemical.
Because the heat has to react with all that stuff and fluid and color. It's because the gunpowder.
This is talking about reaction.
It's because the gunpowder the heat reacts with the gunpowder floats and then it.
So there's light and heat being produced. This is visible. Let's do some examples. Is ice melting a physical property, physical change, chemical property, or chemical change?
Physical change.
So something is changing and it's physical. So this would be a physical change. Water boils at 100 degrees Celsius. Is this a physical property, a physical change, chemical property, chemical change?
Chemical.
Yes, this is a property of water, and it's physical. It's physical because it's still water. So it's physical because it's still water. And it's a property because we're not actually heating it up. This is me just telling you that at 100 degrees Celsius, it would become steam. I'm not saying we're doing it. I'm just saying it's something else. So, gasoline is flammable.
Chemical.
So, chemical property. It's chemical because flammability has to react with oxygen to occur. And it's a property because we're not changing anything. I'm just telling you gasoline is flammable. Burning gasoline is what? It's a chemical change. We're actually doing something to the gasoline, so we're changing it. And this is, again, a chemical change. Alright, cutting a stick in half. So this would be a physical change. We're not changing the fact it's still wood or still stick, and we're changing it. Let's do some another example. Stainless steel is resistant to rusting. What would this be? It's a chemical property of stainless steel.
Is it completely resistant though?
No, you can eventually get the rust.
Then
Is-
why is it not stable?
Because it's a marketing thing.
It should be like
Do you know the funniest thing I've ever seen marketing was someone was selling sugar and say it was 0 calories and contained no sugar. So the little individual packets of sugar, in order for it to meet the legal definition of being sugar-free, it has to have like less than 0.5 grams or something like that.
But it's still in sugar.
But they were selling it in 0.49 grams packets, which I forget how I read this. It was somehow they got it to where it's like mostly sugar, but because the legal definition was so loose that because some things contain traces of sugar, it was I found it hilarious that the main ingredient was sugar, but they were selling it sugar free because they could legally do it.
I don't know how you pick that up.
Because I think it's like in order to meet the definition of being sugar free, because it's impossible for like it to be completely sugar free. Some foods, it has to be less than 0.5 grams per serving. So they just made 0.49 grams is equal to 1 serving, and, and like it met the legal definition for themselves as sugar free. Yeah, I mean, it's legal, but like, let's see. I think that's mostly up. I just want to make sure y'all were good on the difference between a property and a change. Have you all turned in yesterday's work?
Oh wait, no, I didn't put it on. Keep your mask on. I did homework until I can.
You should be able to finish that, right? So number 1, heat conductivity. What would that be? Physical property. Heating something up doesn't change it chemically. It would be a physical property. We're not actually heating it up. We're just mentioning how conductive it is with heat. How easy is this lesson so far? This is literally the entire test. Yep. Which means you should study, pay attention, and try to make 100 on this test. So that you can do bad on the next 2 tests. And ace this. It gives you some wiggle room if you make sure you can get 100 on this. That's the only thing on this entire. There is one additional thing on the test. It would be. I haven't covered this yet. something with a definite shape and definite volume. Now let's make it something with an indefinite shape and definite volume. What is that? What is the word indefinite? Means indefinite means can change, and definite means doesn't change. So what is something that can change its shape but doesn't change its volume? That'd be a liquid.
Alright, so if something dissolves in something, you can get it back out.
Yes.
Is milk sour considered a physical change?
So when milk is souring, can you unsour it?
No.
So that means you can't reverse it. So that indicates it's a blah. This is basically saying milk spoiling. Milk souring is the same thing as saying milk spoiling. Is physical is reversible. Chemical is not reversible. I don't know about you, but once my milk spoils, I usually throw it away.
What?
At least, well, you at least have to drink it spoiled. You don't unspoil it.
What's sublimation?
That is going from a solid to a gas. There's a phase change, like dry ice evaporating. You can turn it back into a solid by getting really cold temperatures. So, CO2 deposition point. Do y'all know what brittleness is?
Like breaking it, like
How much you can bend it before it snaps and breaks?
that's a physical property.
Mm-hmm. The opposite of that would be malleability. Kind of the opposite.
Incombustible means it can explode, something like that.
Can catch on fire.
Acid resistant, and that
Is the ability to not react with the acid.
what does it mean by shortening the mountain? Cutting it? I mean, shortening the mountain.
This is talking about food shortening. Have you ever heard of food shortening?
What is that shortening the mountain?
Do you know what shortening is in context of food and baking? This is shortening. Ever seen Crisco grease or vegetable oil cream or whatever it's called?
Yes, sir.
This is shortening. If you read the very small letter here, it says all vegetable shortening. It's basically kind of like a fat. So it's saying this melting. So shortening is any fat that is solid at room temperature.
Oh, so like bacon grease?
Yeah, bacon grease. That is what shortening is.
And length of metal object. Does that just mean like an inches and feet?
Mm-hmm. So you have a 1 foot rod and you cut an inch off of it. Though butter is not usually called shortening, technically you can say it's butter too. Margarine is basically shortening. Margarine is a type of shortening. So basically butter melting.
I don't understand.
26.
23.
So scientists break up water into oxygen and hydrogen. So you have H2O and you break it apart into hydrogen and oxygen.
So, yeah. And tonic is where it gets black spot. Right?
Repeat that?
So when tonic is where it gets like black spot.
Yes. So when this colors. Your mask on. Cody! You left one blank.
What does magnetizing mean?
Making it magnetic.
Which one do we? Oh. That's this one.
Wouldn't you like to do real physics?
Oh. Oh.
So, we have a box that's on a spherical ball, and we let it go. It falls down, hits this box, and sticks to it and goes up. How high will it slide up the ball? It'll go up 1/4 the radius in height. All you have to do is use a couple of conservation laws.
A couple?
Multiple times.
A couple letters. A whole page. Yeah.
The only numbers is 2 and square. Everything else is... I think 2 does combine together. 2 times 2 is 4. Other than that, why use numbers?
Wait, and change of owner, is that a chemical change?
So, so the older, yes, it would be. It's asking you about when milk's. So how you tell milk is chemically changed? It's when you smell it when it sours.
Is it cheese? Sour milk? Cheese. Isn't that sour milk?
It's.
Yogurt's
Not exactly, but kinda.
Oh no, it's not.